Thanks, mini mathematicians, for doing your best on 6.1c. Let's talk about how you did. So looking at listing the said numbers we've learned so far, we've talked about natural numbers, whole numbers, integers, rational numbers, and irrational numbers a little bit. Are all numbers rational? Do you see the word ratio in there? No, they're not always rational. Some numbers cannot be written as a fraction, such as irrational numbers, like my favorite, pi. Can square root of 2 be written as a fraction where the numerator and denominator are integers? No, square root of 2 is irrational, meaning it cannot be written as a ratio. A square root of a non-perfect square is a never-ending and never-repeating decimal that cannot be written as a ratio of two integers. We also call that non-terminating, non-repeating. That means never-ending and never-repeating. So here is a diagram of the real number system. Yours probably looks a lot nicer than mine, but we start with the natural numbers, and all natural numbers are also whole numbers, integers, and rational numbers. Natural numbers start at 1 and go on. Whole numbers introduce 0. All natural numbers are included in the whole numbers. Integers include all the natural numbers and all the whole numbers, and then our opposites, so our negatives. And then the rational numbers include all the naturals, all the wholes, all the integers, and then any number that can be written as a fraction. Last class, we looked at which repeating decimals can be written as fractions, so we know decimals that have a bar over them are also rational numbers, because they can be written as a fraction, just like we looked at last class. Also part of the real number system are irrational numbers. Irrational numbers are part of the real number system because they can be put on the real number line. And that's what we're doing the second half of today's class. So irrational numbers are those non-repeating and non-terminating decimals, just like pi. Looking at the next problem you had to do, square root of negative 49 or radical negative 49 is not a real number. It's called an imaginary number. It cannot be placed on the real number line, so it's not a real number. I cannot take the square root of a negative number because no real number times itself can equal a negative value. If I wanted to know the difference between the negative of radical 4 and the radical of negative 4, negative radical 4, or the opposite of radical 4, is negative 2. It's an integer. It's the opposite of radical 4. But the square root, or radical negative 4, is not real. It's not rational and it's not irrational. No number times itself is negative. So taking a look at our answers for 7 through 20, take a moment and look how, notice I have real and irrational switched on my answer key because I thought it made more sense to have if it was real and then irrational on the other side. So please note that difference on your document. Okay, all this is available on my website if you still need to check your answers. And, oops, something you may want to note, number 20, if the side length of a square with an area of 8, if the area is 8, the side length is radical 8. Okay, let's get started on our next lesson. Please pass out 6.1d classwork and we'll get started on that now. Pause the video to pass out the classwork and then we'll continue with the next lesson. Thank you. Okay, so because we talked about how irrational numbers can be placed on the real number line, that's why they're real numbers, we're going to talk about approximating the value of irrational numbers so we can use them in calculations. So let's talk about our lesson. How can you determine a good approximation for a numerical value of an irrational number? The number pi is an irrational number. The decimal expansion of pi to 8 decimal places is 3.14159265, and so on. On the number line, we know pi lies somewhere between 3 and 4. Show its approximate location on the number line. Scale the number line. So I scaled the number line for you. Notice this is going to be our approximation to the nearest whole number. Because I know that pi is approximately 3.1, given the digits to 8 decimal places, I know that it's between 3 and 4, but what is it closer to? That's right, it's closer to 3. So let's place pi on our number line between 3 and 4, but closer to 3. If I want my estimation or approximation to be more accurate, I want more decimal places. So let's zoom in on the interval between 3 and 4. The location of pi then is accurate to the tenths place. Show its approximate location in the number line and scale the number line below. So this is the approximation to the nearest tenth. So we know that we have 3.1 and then 4. So if we need to scale our number line, I'm going to show the tenths place. So we're going to go between 3.0 and 4.0. I almost wish this was a touch screen and I could just zoom in, but I can't. So let's start writing. 3.0, 3.1, 3.2, 3.3, 3.4. Okay, keep going. See if you can beat me. I'm done. Okay, you should probably be done almost by now also. So let's zoom in and think about 3.14. Well, that's between 3.1 and 3.2. 3 and 1/10 and 3 and 2/10. But which is it more close to? What's more accurate? You're right, it's going to be closer to 3.1. So we're going to put pi in between 3.1, or 3 and 1/10 and 3 and 2/10, but closer to 3 and 1/10. I want this to be more accurate, so let's zoom in on that number line one more time to go to the nearest hundredths. So we know that pi to the hundredths is 3.14. We have to look next door to see how accurate. So that's going to be a 1. So I'm going to add my zeros to then scale my number line. 3.10, then 3.11, 3.12, 3.13, 3.14. You might be done by now. I'm taking a little bit longer. Okay, pretty nice. Now I know that pi is between 3.14, but it's more than 3.14, so it's in between 3.14 and 3.15. Which one is it closer to? You're right, closer to 3.14. I'm going to put it really, really close to that. There's pi. You guys, we're not accurate enough. We got to zoom in again. Let's zoom in again to be accurate to the thousandths. So let's see. We're going to zoom in again. So I'm going to add my zeros just so I can put in my numbers more accurately. Okay, I'm going to have to write sideways also to fit this. 3.141, 3.142, 3.143, 3.144, 3.145, 3.146, 3.147, 3.148, 3.149, and then 3.150. I know I did it right. Whew. So now I know that pi is 3.141, and then we want to look at the next digit, which is 5. So we know we are between 3.141 and 3.142. Where should I go in between them if the next number is a 5? That's right, as close to in between both of them as I can. So we can continue this process of zooming in on the location of pi on our number line, and the location will become more exact each time by a factor of 10 because we're in a decimal system. So each time we zoomed in one more factor of 10, producing a more accurate approximation of our irrational number. So let's look at how we can use this to approximate, how about some square roots of some non-perfect squares? And we talked about how square roots of non-perfect squares are irrational. So let's take a look at our next problem. We are going to approximate the value of the following irrational numbers to the indicated degrees of accuracy. So which two integers does radical 30 lie? Which integer is it closer to? So when I want to estimate the square root of 30, I'm going to think, what two perfect squares is 30 in between? Remember, when I think of perfect squares, I'm thinking of 9, 25, 16, 36. So 30, let's think. It's in between which two numbers? Well, radical 30 is in between radical 25, which is 5 squared, and radical 36, which is 6 squared. So taking a look at this, I know that radical 30, if I simplify these two square roots, is between 5 and 6. But which number is 30 closest to? 30 is 5 more than 25 and 6 less than 36. So which integer is it closer to? Closer to, which one is it? Which one is it? You're right, 5. So if I'm going to approximate the location on my number line and scale the number line, this is going to be to the nearest whole number. So between 0 and 10, let's scale our number line. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and we said that radical 30 is in between 5 and 6, but a little bit closer to 5. And another way we can look at this is we can look at the numbers squared line. 1 squared is 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. And then we can think about them being square rooted. And we know that radical 30 is in between radical 25 and radical 36. Using that same idea, we can approximate to more decimal places. So I know radical 30 is about 5, in between 5 and 6. So what I can do next is I can find the radical of 30 accurate to 1 decimal place. So if I want to know but from 1 decimal place, I need to know the nearest tenth, so it's between 5 and 6. So my two endpoints on my new number line are 5.0 and 6.0. So let's fill in our number lines to the 10th. 5.1, 5.2, 5.3, 5.4, 5.5, 5.6, 5.7, 5.8, and 5.9. So I know I'm looking at radical 30, but I don't want to just put that into the calculator. So what I can do is, remember, I can look at the square root of the number being squared. So 5 squared is 25, and 6 squared is 36. Because before I said that the number is closer to 5, I'm going to start squaring my numbers on this side. 5.1 squared is 26.01. So 26.01. I think I should